Good evening, Night City. And we are presenting our presentation of Einstein theory of special relativity and theory of general relative.
Einstein's theory of special relativity. Albert Einstein submitted four papers in Annalen der Physik in 1905. His discoveries about the photoelectric effect earned him his one and only Nobel Prize. Relativity theory, which describes how objects move in different inertial frames of reference.
According to Einstein's special theory of relativity, light travels at the same speed for all observers, including those who are moving relative to one another. And the same rules of physics apply in all inertial reference frame.
How Einstein's theory of special relative changed our perspective on the universe. When Einstein presented his theory of special relative in 1905, it completely changed our understanding of space and time by demonstrating how they work together into a fourth dimension structure. It disproved the Newton theory of absolute time by showing the time is relative that can expand or contract based on the motion of the observer. With its foundation role in physics, cosmology, and technology, the theory fundamental change our understanding of the nature of the universe.
What does EMC squared mean? One of the most famous and well-known equations in all of human history. E equals mc squared. Translates to energy is equal to mass times the speed of light squared. In other words, wrote PBS Nova. Energy and mass are interchangeable. They are in fact just different forms of the same thing. But they're not easily exchanged because the speed of light is already an enormous number. The equation demands that it be multiplied by itself to become even larger. Small amount of mass contains a huge amount of energy. For example, PBS Nova explained, if you could turn every one of the atoms in a paperclip into pure energy, leaving no mass whatsoever, the paperclip would yield the equivalent energy of 18 kilotons of TNT. That's roughly the size of the bomb that destroyed Hiroshima in 1945.
So, what practical travel at relativistic speed is impossible? So, it is impossible to accelerate an object to the speed of light, or for a heavy object to move at the speed of light, according to special relativity.
Okay, so what was physics like before relativity? First, objects in motion or at rest remain in the same state unless changed by an external force. This is often referred to as the concept of inertia. Second, the force applied on an item is equal to the mass multiplied by the object's acceleration. In other words, you can compute how much force is required to move objects of varying masses at varying speeds. Third, there is an equal and opposite response to every action.
Special relativity and quantum mechanics. Quantum mechanics and special relativity are two of the most widely recognized theories to explain how the universe functions. However, the main application of special relativity is very large distance speed and object combining them into a smooth model of the universe. According to Corey Powell in the Guardian events in special relativity are continuous and deterministic, meaning that every action has a direct, particular, and localized consequence. To better understand subatomic particles and their interaction, researcher combined special relative and quantum mechanics, the smooth and the chunky, the very large and the very small, have developed fields such as relativistic quantum mechanics and more recently quantum field theory.
Time dilation. The idea that time moves relative to the observer is just one of the many ramifications of Einstein's general relativity work. Time dilation is the phenomenon whereby an object moving at a high speed perceives time as passing more slowly than it would while at rest.
Okay, prepare for lift off to another topic. Theory of general relativity. So, Albert Einstein, a physicist, developed general relativity to explain how gravity alters space-time. So, and Albert Einstein established general relativity in 1915, and the first solution to the Einstein equation were discovered as early in 1916.
So, how Einstein's theory of general relativity changed our perspective on the universe. When Einstein developed his theory of general relativity in 1915, it completely changed our knowledge of gravity by defining it as the curvature of spacetime brought about by mass and energy. Experiments and observations later verified the predictions of this theory, which included gravitational time dilation and light bending around massive objects. Our understanding of the cosmos was completely altered by general relativity, which improved our understanding of gravity and had profound impact on a wide range of disciplines, including astrophysics and the study of the universe's large-scale structure.
Predictions of general relativity. Those predictions made by relativity have been verified by observation and experiments. For the first one is gravitational time dilation. A stronger gravitational field slows down time. Experiments using extremely precise atomic clocks positioned at various elevations have verified this effect. For the second one is black holes. Black holes are predicted by general relativity to form because of their extreme gravity, which prevents anything from escaping, not even light. For the last one is curvature of space-time. According to general relativity, mass, mass and energy causes space-time to curve, not a force, which is what we refers to a what we to prefer the exact calculation of planetary orbits and the behavior of light in gravitational field to have verified this idea. Liit.
So, how does the black holes form? The collapse of a massive star's core results in the formation of stellar black holes. This results in the explosion of a supernova. So, a supernova is a star that explodes, launching a portion of the star into space. And that's all, Night City. Thank you for listening our presentation. So, here's the reference. That's it.
Okay, thank you so much for listening to us again. My name is Josh Orio.
My name is Lance Christian Rodriguez.
My name is Yurikco Gamboa.
My name is Stephen Calde.
That's it. Thank you.
And once again, thank you.
Thank you.
Bye.